Maritime transport utilizes lowest grade of fuel to run its propelling plant. This is one of the reasons which make it the cheapest mode for transporting goods to different countries. A mid-sized container ship consumes approximately 200 to 400 metric ton of fuel on a daily basis, depending upon the operation, speed, and engine efficiency. Before using the low-grade oil, such as heavy fuel oil for combustion in the engine, it is treated on ship at various levels. First, the FO is internally transferred from bunker to settling tanks. In the settling tank, it is stored and heated up to 50 to 60 degrees to separate it from water, which is drained off from the bottom. The oil in the settling tank is drawn out by the feed pump, which delivers the fuel to a thermostatically controlled heater to raise the fuel temperature to about 80 to 90 degrees Celsius, before supplying it to the centrifugal separator. Then, the oil is further treated in purifier, in which the water and solid particles are separated from the oil. The purified oil is transferred into the service tank, from where the oil is directly fed to the marine engines and ship's boiler. The centrifuge separator is an essential machinery in the engine room used for purification of fuel oil and for efficient combustion. It is a bowl carrying the dirty fuel, which is rotated at high speed using external force. The external force is generated by the electrical motor, driving the bowl shaft either by gear or using a belt drive. The centrifugal force developed by the motor exerts a force on all particles in the fuel. The heavy particles, like solids and water, are thrown to the periphery of the bowl, from where they are separated. To understand the construction of the centrifuge separator, it can be divided into two sections: the bowl assembly and the driving assembly. The shaft assembly is driven by an electrical motor in one of the two ways: using gears, using a belt. In the gear drive arrangement, the motion from the motor is transmitted using gears. The motor is connected to a horizontal shaft which drives the vertical shaft carrying the bowl through gear and pinion arrangement. The horizontal shaft is connected to the motor using frictional clutches. The gear-driven separator has an advantage of having an attached oil gear pump at the other end of the horizontal shaft, which acts as a supply pump for purifier. The horizontal shaft is carried on two ball bearings, one near the motor end and the other towards the attached gear pump end. The horizontal shaft is also provided with oil seals near the casing at both ends to avoid leakage of gear case oil. The attached gear pump is provided with a seal to prevent leakage of fuel oil into the purifier lube oil chamber. The vertical shaft is fitted with thrust bearing arrangements at the bottom, as it is subjected to compression and dynamic loading. The top bearing is also provided with springs to compensate the side thrust. The pinion of the shaft on the gear tooth, which allows the driving mechanism and rotates the bowl. The belt-driven purifier are an excellent choice, as they have an advantage of less moving and heavier parts, which results in less load on the driving system. Usually in this setup, the motor is installed vertically, which drives the vertical shaft carrying the purifier bowl via a belt. The motor shaft is provided with a frictional clutch drum, over which the belt is strapped. The vertical shaft is fitted with thrust-bearing arrangement at the bottom to tackle compression and dynamic loading. The bowl assembly is kept separate from the shaft and gear case area using a sealing ring on the operating water disc. The operating water disc is fitted on the bottom part of the bowl chamber, which provides the pressurized water to lift or close the bowl. The bowl comprises of top conical bowl, sliding bowl, multiple discs, top disc, tubular distribution holder, and bottom main bowl. The tubular disc holder acts as a liquid supply tube for the discs and bowl assembly. The liquid enters from the center of the disc holder. The outer surface is provided with vertical slots and ribs, which holds the discs together. The bottom periphery is provided with distribution holes, through which oil comes out and goes inside the disc stack. A locking pin and dowel slot keep the holder on top of sliding bowl. The discs are inserted over the ribs of the holder. The bottom side of each disc is provided with distribution holes. They have raised stamping on the bottom to hold the disc and to provide a minimum gap between each disc for fluid mixture to travel. Once all the discs are placed on the disc holder, it is covered with the top disc, which has a greater diameter than the rest of the discs. The purifier oil is taken out from the gap between the top disc and the tubular holder. To lock these disc arrangements in place, it is covered with a top conical bowl. The bottom bowl carrying the disc assembly and the top bowl covering it are locked together by use of a large locking ring. If the separator is to be used as a purifier, a gravity disc is additionally fitted on top of the distributor. A centripetal pump is also fitted on top of the bowl and disc assembly. It is a fixed centrifugal style impeller which is mounted in the light phase outlet, drawing the oil and discharging it at pressure sufficient to deliver it to the receiving tank. The top portion, which comprises of gravity disc, centripetal pump, and top covering cone, are also locked together using a small locking ring. The separation in the purifier happens based on the principle of difference in the specific gravity of various liquids and solids. If two different grades of liquid are mixed together in a tank and are left for some time, the denser fluid and solid particles will go down, and the lighter fluid will float on the surface. Suppose there is oil mixed with water and solid particles kept in a tank. As per the gravity separation, the solids will settle in the bottom. The water, being heavier than oil, will settle above the solids. The oil, which is the lighter liquid, will settle on the top. If we add angle baffle plates to the tank, the underside of each parallel plate provides more surface for suspended oil droplets to combine into larger globules and come up. The solid particle will also slide down the surface of each parallel plate. This allows the denser liquid and solids to settle at the bottom, while the lighter fluid will rise up to separation. Now let's understand the same concept when applied in a centrifugal separator. When the dirty oil enters the separator, it passes through plates and pushed upwards by the fluid flow. Fluid moving between the two plates has a velocity greatest at midpoint and minimum when approaching the plates. This is because the centrifugal force will retard the horizontal component of the movement for the heavier particles, causing them to approach the underside of the top disc, reducing its flow velocity. The lighter fluid rises due to the push of dirty liquid flow entering the separator. For heavier fluids and solids, the centrifugal force eventually overcomes the upward force acting on the particles due to fluid movement, and they start to move towards the outer rim and get collected near the sludge port. In this way, it can be seen that reducing the flow rate to a separator will tend to increase the quality of the output.